Good evening and welcome to my channel. In the silent cradle of the early solar system, long before the planets took their final form, a cloud of gas and dust circled a young and violent sun. The newborn star was fierce and unsteady, bursting with solar winds that swept through the swirling disk of cosmic debris. Within that churning sea of elements, hydrogen and helium, the two lightest, most ancient gases in the universe, began to gather. Gravity, quiet but relentless, pulled them together, grain by grain, particle by particle, until a giant began to take shape. Jupiter was the first to rise from the dust, the first to claim dominion in the young solar system. It was born not through gentle creation, but through hunger, an insatiable appetite for mass. Every swirling tendril of gas that drifted near was pulled in by its growing gravity. The more it devoured, the stronger it became, until its presence shaped the destiny of everything around it. While the rocky worlds of Mercury, Venus, Earth, and Mars were still forming, mere clusters of molten stone, Jupiter had already become a colossus. It gathered hydrogen and helium directly from the nebular cloud, growing so massive that it might have become a star had it continued. But fate stopped it short. Its gravity was powerful, but not enough to ignite nuclear fusion. Instead of light, it became a world of storms. Billions of years ago, the air around it boiled with energy. Lightning flashed through its vast, thickening clouds. The planet's outer layers churned in ceaseless motion, sculpted by winds that reached hundreds of kilometers per hour. Deep within its core, a strange heat was born. The leftover fire of creation. That heat has never fully died. Even today, Jupiter radiates more energy than it receives from the Sun, as though the memory of its birth still glows within it. In its youth, Jupiter played a violent role. Its immense gravity disturbed the orbits of countless asteroids and planetesimals that once drifted between it and the newborn Sun. Some were flung outward into the icy darkness beyond Neptune. Others were hurled inward, colliding with the growing terrestrial planets. The scars of that era can still be seen today, etched upon the cratered surfaces of Mercury, the Moon, and Mars. Every mark tells a story of chaos shaped by Jupiter's hand. Without Jupiter, Earth might never have found balance. Its gravity stabilized the inner solar system, sweeping away much of the debris that could have prevented life from flourishing. At the same time, it acted as both protector and destroyer, deflecting some comets, capturing others, and occasionally sending a few hurtling toward the Sun. Yet even in its violence, Jupiter's presence helped craft the stage upon which life would one day emerge. As time passed, the chaos began to settle. The Sun matured into steady brilliance. The inner worlds cooled and hardened. Jupiter continued its slow revolution, serene yet watchful. Around it, a vast family began to form, dozens of moons, each born from the same swirling cloud of material that had once fed the planet itself. They coalesced from dust and ice, captured by gravity into orbits both graceful and complex. This was the birth of a miniature solar system ruled by one immense world. In this early age, Jupiter's storms were unimaginable in scale. The planet's deep atmosphere, made of hydrogen, helium, and traces of ammonia and methane, was restless and wild. Heat rose from below, sunlight poured from above, and the two forces collided to create endless turbulence. The planet became a living painting of motion, bands of color twisting around its belly, where light and shadow shifted with hypnotic rhythm. Even now, after 4.5 billion years, those patterns remain, proof that the same forces still dance across its face. Its magnetic field grew alongside its size. Deep inside, under pressures millions of times greater than Earth's atmosphere, hydrogen transformed. Squeezed by gravity, it became metallic, a liquid conductor unlike anything on our world. This ocean of metallic hydrogen, spinning rapidly as the planet rotated, generated a magnetic field so powerful that it extends millions of kilometers into space. It is the largest magnetic field of any planet in the solar system, strong enough to trap charged particles and create radiation belts that dwarf Earth's Van Allen belts. That invisible power shapes everything around the planet. Jupiter's magnetic field interacts with the solar wind, producing auroras brighter and more energetic than any seen on Earth. Near its poles, charged particles collide with the upper atmosphere, releasing streams of ultraviolet light that shimmer and dance in silence. For spacecraft observing from orbit, these auroras are breathtaking. Vast, luminous rings that wrap around the planet's poles, glowing with the energy of the sun itself. Even now, the story of Jupiter's birth is written in its composition. Scientists know that it holds the same primordial gases that filled the solar system before any planet formed. Within its clouds are traces of water vapor, methane, ammonia, and sulfur compounds, the same ingredients that, on Earth, became part of oceans and air. To study Jupiter is to study the early solar system itself, preserved in living motion. It is easy to forget that Jupiter is not a solid world. There is no surface, no ground to stand upon. From its outermost clouds to its mysterious center, it transitions from gas to liquid, from liquid to metal, in a continuum that defies imagination. If one were to descend through its atmosphere, there would be no clear boundary, only deepening color, thickening air, rising pressure, and growing heat. The journey would end not in impact, but in dissolution, the traveler becoming part of the storm. Yet for all its violence, there is serenity in Jupiter's existence. It moves in perfect rhythm around the sun, its immense orbit taking nearly 12 Earth years to complete. From afar, it appears calm, a glowing sphere suspended in darkness. Only upon closer look does its true nature reveal itself. The ceaseless motion of gases, the hidden flashes of lightning, the vast rotation of an ancient heart that has never stopped beating. Jupiter's formation was a turning point in cosmic history. Its gravity influenced not only the planets that followed, but also the comets, asteroids, and icy bodies that would one day bring water and organic material to Earth. Some scientists believe that Jupiter's gravitational push sent countless frozen comets toward the inner solar system, seeding the early Earth with the raw materials for life. If that is true, then every ocean wave, every drop of rain, every living breath owes a quiet debt to the giant. Even in modern times, Jupiter remains a living laboratory of cosmic evolution. The Juno spacecraft, launched by NASA, orbits close to the planet, measuring its gravity, magnetic field, and atmosphere in exquisite detail. Each orbit peels away another layer of mystery. Through Juno's eyes, we see storms that reach deep into the planet, clouds of ammonia that rise and fall like tides, and heat that glows faintly beneath the clouds. The data reveals a world both familiar and alien, a planet that should not be possible, yet exists as if to remind us how little we truly know. There is poetry in the way Jupiter endures. It has seen the sun grow old, watched comets burn and planets evolve. Its clouds change daily, yet the essence of its being has remained the same for billions of years. It stands as the memory of creation, the first-born child of the sun, the one that never lost its fire. Its beauty lies not just in its size or power, but in its balance. The same gravity that creates destruction also nurtures stability. The same storms that rage for centuries are shaped by the same forces that make the planet glow in silent harmony. Jupiter is the contradiction that defines nature, chaos and calm intertwined. Perhaps that is why it fascinates us still. To gaze upon Jupiter through a telescope is to look into the deep past, to witness the ancient craftsmanship of the universe, frozen yet alive. The bands and colours are more than patterns of weather, they are echoes of formation. Whispers of the time when stars and planets were one. In that sense, Jupiter is not just a planet. It is a story still being written, a bridge between what was and what is. The sun will one day fade, its brilliance dimming as it becomes a red giant. Long after Earth has been scorched and reduced to dust, Jupiter will remain drifting in the outer light of a dying star. It will still hold its moons, still spin with ageless momentum. And as the solar system cools into shadow, the giant planet will continue to glow faintly from within, as though remembering the dawn of time. For now, it turns quietly in the Black Sea, a monument to creation, vast, mysterious, and eternal. The first of the giants, the king of planets, the silent witness to everything that ever was and everything that will come. From afar, Jupiter's face appears like flowing marble, wide belts of cream and ochre sliding past each other in quiet majesty. Yet hidden within that beauty lies unending violence. The planet's atmosphere is a theatre of motion. Currents colliding, waves of temperature rising and falling. Pressure and chemistry combining to paint a living canvas that never repeats itself. And in that churning wilderness, one storm rises above all others, the Great Red Spot. No human being alive has ever known a time when the Great Red Spot did not exist. When the first telescopes were turned toward Jupiter in the 17th century, observers described a faint oval blemish near the planet's southern hemisphere, drifting slowly across the disk. Centuries later, that same mark still turns, an oval of crimson and rust larger than 3 Earths set side by side. For generation after generation, it has burned against the pale clouds, the longest continuous storm in the known universe. What sustains such persistence? The answer begins with energy. Jupiter spins with astonishing speed, completing a full rotation in less than 10 hours. That rotation creates powerful jet streams, alternating eastward and westward winds that wrap around the planet like invisible ribbons. Between these streams, turbulence builds, forming giant vortices where opposing flows meet. The Great Red Spot is one such vortex, born from the clash of east and west moving bands. But while smaller storms merge and die, this one survived, feeding upon the endless supply of heat rising from below. Inside Jupiter, leftover energy from formation continues to rise through the deep layers. The planet emits nearly twice as much heat as it receives from the sun. That internal warmth drives convection, massive bubbles of gas rising upward, cooling, then sinking again. Each cycle releases tremendous power, and when that power meets the fast spin of the planet, it twists into colossal spirals. The Great Red Spot is the crown of those spirals, a storm whose roots may reach hundreds of kilometers beneath the cloud tops. Seen from orbit, its texture is mesmerizing. High above the main cloud decks float delicate veils of ammonia ice, their edges tinted by chemicals dredged up from below. At certain times, telescopes capture hints of orange, salmon, and even deep brick red. The color likely comes from compounds altered by ultraviolet sunlight, complex molecules of sulfur and phosphorus that stain the upper haze. These shifting tones are the storm's signature, an ever-changing spectrum that tells scientists how deep its layers mix and how the chemistry evolves. The winds that race around the rim of the Great Red Spot reach speeds of more than 400 kilometers per hour. Yet within the center, motion slows, the eye of calm in a rotating world of chaos. If one could hover safely above it, the view would be surreal. Cloud towers rising tens of kilometers high, shadows drifting over lower bands, lightning flickering silently through translucent plumes. There is no solid surface below, no land to break the flow, only depth without end. Each swirl you see from above continues downward into pressure and heat until physics itself begins to bend. The Great Red Spot does not exist in isolation. Around it, fleets of smaller vortices constantly form and fade. Some merge with the giant, giving it new strength, others are devoured. Observations from the Juno spacecraft have shown that these interactions create waves that ripple through the surrounding belts, shaping the entire hemisphere's weather. The giant storm is not merely a feature, it is a heartbeat, regulating the circulation of Jupiter's atmosphere like a vast pump. Over the centuries, scientists have watched the storm shrink. Once, its length exceeded 40,000 kilometers. Today it spans roughly half that size. Its color has faded at times, then deepened again, as if breathing through the ages. Some predict it may one day disappear, dissolving into the surrounding bands after centuries of dominance. Yet even if it fades, its influence will linger. For every generation of astronomers who have looked up and seen that red eye staring back, it has been a reminder of nature's scale and endurance. Beyond its hypnotic beauty, the Great Red Spot is a window into physics that we cannot recreate on Earth. The pressures, temperatures, and speeds within it exist nowhere else in the solar system outside the gas giants. Studying it helps scientists understand turbulence, the same phenomenon that shapes ocean currents, weather patterns, and even the dynamics of stars. The mathematics behind those swirling gases describe the fundamental language of motion. Jupiter simply performs the equation in plain sight. Imagine descending through the planet's upper clouds. The sunlight above fades into golden haze. Droplets of ammonia snow swirl in thin air, merging into thicker mist. The deeper you go, the more the color changes, from pale cream to amber, from amber to a copper glow. Around you, the winds quicken. Sound cannot travel far in such a medium, but the pressure builds silently. Below, layers of water vapor and ammonium hydrosulfide take over, creating a strange rain that never reaches a surface. Each drop falls until it turns to vapor again, trapped in endless circulation. The storm below you stretches farther than sight, spinning through levels where hydrogen begins to glow faintly from heat. At its base lies the boundary where gas becomes fluid. Here hydrogen acts as a liquid, and lightning bolts flash with energies thousands of times greater than those on Earth. They illuminate clouds the size of continents. Each flash is a sculpture of raw power, a reminder that Jupiter's weather is not weather as we know it. It is a planetary engine converting gravitational energy into motion. The Great Red Spot is the visible crest of that unseen ocean of dynamics. The storm's rhythm affects even the magnetic environment above the planet. Jupiter's magnetosphere captures charged particles from the Sun and funnels them toward the poles. But the rotating atmosphere modifies this field, causing auroras to flicker in patterns synchronized with deep atmospheric waves. In that sense, the Great Red Spot is tied to lights that dance millions of kilometers above it. It is part of an orchestra whose notes travel from the metallic heart of the planet to the edge of space. From Earth, the storm's persistence has shaped our imagination. Early astronomers thought it might be a solid island or even a gigantic hole, revealing the fiery interior. Later, when spacecraft sent close-up images, people were astonished to see texture. Turbulent clouds, eddies, and filaments that seemed to flow like oil on water. Each mission, Voyager, Galileo, Juno, has deepened the wonder. The photographs are never still, each reveals another layer of movement. It is as if the planet resists being captured, insisting that its life cannot be frozen into a single frame. When you watch the Great Red Spot drift across Jupiter's face through a telescope, you are witnessing time compressed. The light reaching your eye left the planet nearly an hour ago, having crossed hundreds of millions of kilometers of space. In that time, the storm has continued to turn unseen, unbothered. For most of human history it has been there, a constant against which our brief lives can be measured. Empires have risen and fallen, the storm has turned. Languages have been born and lost, the storm has turned. Whole species have vanished, still it turns. Yet nothing lasts forever, not even giants. As energy within Jupiter redistributes, as atmospheric chemistry changes, the great vortex may slowly unwind. If someday it fades completely, the planet will not be lesser. It will simply change its pattern. Another storm, perhaps smaller, perhaps grander, will take its place, because the forces that gave birth to it still burn beneath the clouds. Jupiter's essence is motion, and motion never ceases. Understanding the Great Red Spot helps us glimpse how nature organizes chaos. The storm is stable because it feeds upon gradients, differences in temperature, rotation, and density. Remove those contrasts, and calm would return. But as long as Jupiter spins rapidly and releases heat from within, turbulence is inevitable. On Earth, hurricanes last days. On Jupiter, they can last centuries. Time itself bends to the scale of the planet. For those who study worlds beyond our solar system, Jupiter's storm offers clues about exoplanets, gas giants circling other stars. Many of those distant worlds show signs of massive weather systems, and models built from Jupiter's data help explain them. Each time we look at the Great Red Spot, we also look outward, imagining thousands of unseen vortices swirling in alien skies. There is also a quiet lesson in humility. The great red spot is not aware of us, yet its image has inspired art, science, and philosophy for centuries. It reminds us that grandeur does not require witness. The universe performs its beauty, whether or not eyes are there to see it. Jupiter's storm has been dancing long before we named it, and it will continue long after our names are forgotten. Above all, the great red spot reveals that permanence and change are one. Its shape shifts every decade, its colors breathe in cycles, but its spirit, the eternal movement of energy seeking balance, remains constant. Perhaps that is why watching it can feel strangely calming. In its violence, there is order; in its chaos, repetition. The storm turns endlessly, and in that endlessness there is peace. As Jupiter completes its slow journey around the Sun, the great red spot continues to glide across its southern belt, marking time not in hours or days, but in revolutions of centuries. It is both monument and motion, a relic of the planet's youth and a living process renewed each moment. And while telescopes track its every turn, the true wonder lies not only in what we see, but in what it represents. The capacity of nature to sustain magnificence without exhaustion. When night falls on Earth and the planet rises bright in the eastern sky, the red storm is there, hidden by distance but unwavering. Its light, reflected from the sun, crosses the void and enters our eyes as a gentle shimmer. In that shimmer is the story of endurance, of forces far greater than us moving with perfect grace. To contemplate it is to feel small, and in that smallness, strangely at home. Beneath the painted clouds of Jupiter lies a world no human eye will ever see. What we observe from space, those swirling storms, marbled belts, and shimmering auroras, are only the uppermost whispers of a planet so vast and layered that its interior defies ordinary imagination. For centuries, astronomers wondered what might exist below the clouds. Was there a solid surface buried beneath the pressure? Was the planet hollow, or did it hold an ocean of liquid gas? Each answer revealed another question. To this day, Jupiter's depths remain one of the most mysterious regions in our solar system, a hidden kingdom of crushing pressure, unimaginable temperature, and elemental transformation. The journey downward begins with light and silence. The topmost atmosphere is a place of high winds and frozen crystals. Ammonia snow swirling through golden haze. Sunlight reflects from these thin veils, giving the planet its glowing face. Descend only a few dozen kilometers, and the familiar radiance fades. Here clouds thicken. The temperature rises sharply, and lightning flashes more frequently, illuminating towers of water vapor taller than Mount Everest. The pressure doubles, then triples, crushing anything not built to withstand forces far beyond Earth's atmosphere. As the descent continues, gases compress into fluid. There is no clear line dividing air from liquid. Only a gradual shift where hydrogen and helium, the planet's main ingredients, begin to behave differently. The molecules, squeezed so tightly, can no longer remain as free gas. They crowd together, flowing like an ocean without surface or bottom. This is Jupiter's molecular layer, a world of storms suspended in deep liquid sky. Every drop is hydrogen, every current a river of gas turned to fluid under the weight of the planet's own gravity. It is here, within this endless ocean of invisible matter, that energy from Jupiter's formation continues to rise. Long ago, when the solar system was young, Jupiter accumulated its mass by devouring gas and dust left over from the Sun's birth. The heat of that accretion, the pressure of material falling inward, has never fully escaped. Even now, billions of years later, the planet radiates more heat than it receives from the Sun. That inner warmth fuels the circulation of clouds above and gives rise to the storms that dance on its surface. The great red spot, the belts and zones, the lightning, all are outward expressions of the furnace deep below. The farther one plunges into that depth, the more alien the environment becomes. Hydrogen, the simplest and most abundant element in the universe, begins to change its nature. Under extreme pressure, millions of times that of Earth's sea level, it transforms from a transparent gas into a shimmering metallic fluid. Electrons, normally bound to individual atoms, break free and begin to move collectively, allowing the substance to conduct electricity like metal. This layer is unlike anything found naturally on Earth. It is not solid, not gaseous, not liquid in any familiar sense. It is something in between a plasma, like sea where magnetism and heat weave together in perpetual motion. This metallic hydrogen is thought to be the source of Jupiter's enormous magnetic field, the largest in the solar system. As the planet spins, completing one rotation every 10 hours, the fluid metallic layer churns and twists. These movements act like a giant dynamo, generating a magnetic field so strong it extends millions of kilometers into space. The field captures charged particles from the Sun and from Jupiter's volcanic moon, Io, shaping them into radiant belts of radiation that encircle the planet. This invisible storm of magnetism is so intense that it would be deadly to unprotected spacecraft. And yet, it is also one of the most fascinating laboratories for studying how magnetic fields work on cosmic scales. Deep within that magnetic heart, scientists suspect a core, a dense, heavy region composed of rock metal and exotic ices. For many years, this core was imagined as a solid sphere about the size of Earth, lying beneath tens of thousands of kilometers of hydrogen. But data from the Juno spacecraft has changed that picture. Gravitational measurements suggest that the core may not be solid at all, but fuzzy, a diffuse blend of heavy elements that mixes gradually with the surrounding metallic hydrogen. It might be more accurate to think of Jupiter's heart not as a gemstone hidden at its center, but as a molten continent suspended in a vast inner sea. The distinction is more than poetic. It tells us how giant planets grow and evolve. When Jupiter first formed, it likely began as a rocky embryo, a massive core that accumulated gas from the solar nebula around it. As more material fell in, the heat of compression could have partially dissolved that core, blurring its boundaries. The result is what we see today, a planet both structured and fluid, both ancient and ever-changing. Its metallic heart breathes heat outward, and in doing so, it powers the planetary engine that still shapes its clouds. Imagine, for a moment, descending all the way to that heart. The air above has become dense enough to behave like a liquid. Every breath would weigh tons. The temperature surpasses 10,000 degrees Celsius, hotter than the surface of the Sun. Any craft attempting such a journey would melt long before reaching the core. There is no light here except the faint glow of compressed hydrogen radiating from its own heat. Each movement would feel like swimming through thick, invisible metal. Gravity would pull with enormous force, more than twice that of Earth, and yet the downward direction would be meaningless. For pressure itself defines the landscape. In that hidden realm, the distinction between solid and gas ceases to matter. Physics becomes fluid, and matter behaves as energy's shadow. Hydrogen atoms dance in tight crowds, their electrons forming rivers of charge. The magnetic field born here wraps the entire planet like an unseen cocoon, stretching outward to brush against the orbits of distant moons. Every aurora that flickers near Jupiter's poles is a whisper from this heart, the visible echo of invisible motion below. It is humbling to realize that what we call surface on Jupiter is an illusion. There is no place to stand, no solid ground beneath the storms. If you could somehow descend, there would be no moment when your feet touch down. The deeper you go, the thicker the fluid becomes, until pressure and temperature fuse matter into something resembling the interiors of stars. Jupiter is, in a sense, a failed star, a world that gathered much of the same material as the Sun, but never quite enough to ignite nuclear fusion. Had it been 80 times more massive, its core would have burned hydrogen, and our solar system might have been a double star system, with Earth orbiting between two suns. Instead, Jupiter remains forever on the threshold, a giant world that glows faintly with leftover heat from a fire that never fully began. And yet that unlit furnace is what gave shape to everything we know. Jupiter's immense gravity acted as a cosmic guardian, deflecting comets and asteroids that might otherwise have destroyed the young Earth. It sculpted the early solar system, scattering debris and stabilizing orbits. Without Jupiter, our planet might not have survived long enough for life to arise. The gas giants' hidden depths, for all their violence and mystery, have played a quiet role in the calm skies we see every day. The metallic heart of Jupiter continues to fascinate scientists not just for what it is, but for what it represents, the boundary between planets and stars. It shows how matter behaves when ordinary rules collapse, when atoms are squeezed until they fuse into an ocean of charge. Experiments on Earth have tried to recreate this state using diamond anvils and lasers, compressing hydrogen to extreme densities. For brief moments, the element becomes metallic, just as it does deep inside Jupiter. Those fleeting laboratory flashes offer the faintest glimpse into the planet's secret interior, but they last only milliseconds. In Jupiter, the phenomenon is eternal, sustained by a trillion tons of pressure. As spacecraft continue to orbit the planet, each new measurement refines our understanding. Juno, circling in a polar path, peers beneath the clouds with microwave instruments that can sense layers hundreds of kilometers deep. Gravity mapping allows scientists to infer the density of material below. Bit by bit, a three-dimensional portrait emerges, one of gradual transitions rather than sharp divisions, of heat flowing upward through turbulent channels, of elements swirling and separating in slow motion over millennia. The picture that forms is not a static cross-section, but a living organism, vast and restless. From this perspective, Jupiter becomes more than a planet, it becomes a bridge between worlds. Its upper layers resemble atmosphere, its middle layers resemble ocean, and its inner heart resembles star. Each merges into the next, forming a continuum of existence. The lessons learned here ripple outward to explain the nature of countless other planets orbiting distant suns. The same physics that govern Jupiter's metallic core shape the hearts of those faraway giants, unseen but no less real. The great irony is that the deeper we look into Jupiter, the more it mirrors ourselves, not in form, but in mystery. Every human heart beats with electrical impulses, every neuron fires through currents of charge, every storm of thought arises from unseen motion within. Jupiter's metallic heart is a cosmic reflection of that same principle. Energy circulating through structure, creating patterns from chaos. Its magnetism is its pulse, its clouds the expression of its inner rhythm. When one gazes at Jupiter through a telescope on a still night, the view is serene, bands of colour, smooth and eternal. But beneath that calm image lies an inferno of transformation, an entire universe of physics unfolding in slow grandeur. The planet's hidden depths remind us that the most beautiful surfaces are often born from unseen complexity. The stillness of its appearance conceals the thunder of creation continuing endlessly within. If somehow, through some future technology, we could journey to that heart and survive, we might witness the most alien sunrise imaginable, not of light through air, but of heat through hydrogen, a glow emerging from matter itself. No dawn, no horizon, only pressure giving birth to radiance. It would be silent, eternal, and utterly magnificent. And so Jupiter's hidden depths remain one of the great frontiers, not because we cannot yet reach them, but because they embody the boundary between knowledge and wonder. They remind us that even in an age of machines and measurements, there are places where the universe still keeps its secrets close. The metallic heart of Jupiter beats in darkness, unseen, unending, a reminder that mystery itself is part of creation's design. Orbiting Jupiter are more than 90 known moons, a kingdom of worlds bound to their colossal parent by gravity's invisible chains. Each moves in rhythm around the gas giant, tracing ancient paths across the black canvas of space. Some are small and irregular, mere captured asteroids caught long ago in the planet's pull. But 4 of them, Europa, Ganymede, and Callisto, form a system so complex and alive that it rivals entire planetary families elsewhere. Together, they are called the Galilean moons, named for the first human who glimpsed them through a telescope over 400 years ago. They are not just companions of Jupiter, they are worlds of their own, each telling a different story of creation, destruction, and the potential for life. The first of these, Io, is a world of fire. It orbits closest to Jupiter, locked in a gravitational dance so intense that the very ground beneath its surface heaves and flexes with every rotation. Tidal forces, caused by the tug of Jupiter's immense gravity, stretch and squeeze the moon continuously. The friction from this motion generates extraordinary heat, enough to melt rock and create oceans of magma beneath its crust. As a result, Io is the most volcanically active body in the solar system. Hundreds of volcanoes punctuate its surface, some spewing fountains of molten sulfur tens of kilometers high. If you stood there, though no human ever could, the sky would glow yellow with dust, and you would see plumes of fire rising against the distant arc of Jupiter, enormous and silent in the void. The landscape of Io is both haunting and beautiful, sulfur plains of orange and red, frozen lakes of molten rock, and mountains taller than the Himalayas. But this fury is also a consequence of life, giving motion. The same tidal interactions that torment Io also help maintain the delicate orbital balance of the other moons. Every eruption, every quake, is part of a cosmic rhythm that sustains the system. The heat that makes Io violent keeps its siblings dynamic in their own ways. It is a reminder that in the universe, energy and destruction often share the same origin. Beyond Io lies Europa, perhaps the most mysterious and hopeful of all Jupiter's moons. At first glance, it appears calm, a smooth, pale sphere of ice, its surface streaked with reddish lines and scars. Yet beneath that frozen crust lies an ocean, vast and dark, stretching for tens of kilometers in depth and covering the entire world. This ocean, sealed beneath kilometers of ice, contains more water than all the seas of Earth combined. The heat that keeps it liquid comes from the same tidal forces that tear you apart, though on Europa the energy is gentler, hidden beneath silence. Scientists believe that this subsurface ocean might be one of the most promising places in the solar system to harbour life. No sunlight reaches it, but deep within, vents on the ocean floor may release heat and minerals, just as hydrothermal vents on Earth sustain thriving ecosystems without light. On Europa, similar processes could allow microscopic life to exist. Perhaps primitive, perhaps ancient, perhaps waiting. The idea that beneath the frozen face of this distant moon could lie entire ecosystems, drifting, glowing, unseen, is one of the most humbling thoughts in modern astronomy. If life exists there, it would mean that biology is not an accident of Earth, but a tendency of the universe. The surface of Europa tells a story written in ice. Long cracks and ridges trace the movements of its crust, where sections of frozen shell shift and collide like tectonic plates. Some regions show evidence of chaos terrain, fractured zones where the ice appears to have melted and refrozen, possibly due to upwelling warm water from below. When sunlight glints across these ridges, the moon shines with an almost ethereal glow, as if illuminated from within. Spacecraft that have passed nearby, like Galileo and Juno, have detected plumes of water vapor erupting from the surface, geysers that may connect directly to the hidden ocean below. They rise hundreds of kilometers into space before falling back as frozen rain. Each plume is a message from the deep, a whisper that there is movement, warmth, and perhaps even life beneath the ice. Farther still from Jupiter orbits Ganymede, the largest moon in the solar system, even larger than the planet Mercury. Ganymede is a world of giant towering ridges, icy plains, and ancient grooves that stretch for thousands of kilometers. Unlike any other moon, Ganymede possesses its own magnetic field, a faint echo of Jupiter's colossal one. Scientists believe this magnetism arises from a liquid iron core deep within, a feature once thought to exist only in full-sized planets. Its interior tells a tale of heat and differentiation, a rocky center, a mantle of water ice and liquid, and a frozen crust above. It is a moon that blurs the boundary between moon and planet, a place that might once have been independent had Jupiter not captured it in its gravitational grasp. Ganymede's surface is old, scarred by craters and fractures from ancient impacts, yet it holds a subtle beauty. Bands of bright and dark ice create patterns that resemble frozen oceans under twilight. It may also hide a deep ocean beneath its crust, perhaps several layers of it, stacked between sheets of ice. If so, it too might harbour the ingredients for life, though sealed beneath crushing pressure and eternal darkness. When we look at Ganymede, we see not a satellite but a frozen planet locked in quiet orbit around its giant parent, whispering through electromagnetic waves detectable across the void. Then comes Callisto, the outermost of the Galilean moons and the oldest of them all. Callisto is a relic of the early solar system, its surface unchanged for billions of years. Every crater, every ridge, every scar is a record of impacts stretching back to the dawn of planetary formation. Where Io burns and Europa hides an ocean, Callisto sleeps, cold, inert, and ancient. Yet even this seemingly lifeless world has secrets. Observations suggest a faint, buried layer of liquid beneath its crust. An ocean preserved by residual heat and pressure. If true, even Callisto may conceal a hidden sea, making 3 of Jupiter's 4 great moons potential abodes of water and, perhaps, life. Callisto is also the most distant from Jupiter's radiation belts, making it the safest of the 4 for future exploration or even habitation. Some scientists imagine a human base there one day, shielded from Jupiter's magnetic fury, with access to ice and minerals. From its surface, the view would be magnificent, Jupiter looming in the sky, filling 1/3 of the heavens, bands of cloud drifting across its face and lightning flashing silently across its distant storms. To stand there would be to feel both insignificance and connection, to realize that even a dead world can be a window into the living cosmos. Each of these moons, Europa, Ganymede, Callisto, reveals a different expression of Jupiter's power. Together, they form a miniature solar system shaped by tides, magnetism, and resonance. Their orbits are locked in a gravitational rhythm. For every orbit Ganymede completes, Europa orbits twice and Io 4 times. This resonance keeps the moon's orbits slightly elliptical, ensuring that tidal forces never cease. It is a system in motion, powered by gravity's song, the same force that binds galaxies, drives stars, and shapes the dance of planets. Beyond the Galilean moons, dozens of smaller satellites accompany Jupiter, each with its own story. Some are captured asteroids drawn in from the outer solar system. Others are remnants of collisions, fragments that drift in looping orbits far from the planet. Together, they form a halo of motion around the gas giant, a reminder that even in the silence of space, everything moves in harmony with something greater. When viewed as a whole, the Jovian system feels almost like a scaled down version of the solar system itself. Jupiter acts as a miniature sun, its immense gravity holding a family of diverse worlds, each unique, each reflecting a different chapter of cosmic evolution. It is a laboratory for studying how planets and moons interact, how heat and energy flow through systems, and how life might emerge under conditions far removed from Earth. If our species ever ventures beyond Mars, it is almost certain that our next great frontier will be Jupiter's moons, especially Europa. Future missions are already being planned and built. The European Space Agency's JUICE's Jupiter Icy Moons Explorer and NASA's Europa Clipper are set to explore these icy worlds more closely than ever before. They will fly through Europa's plumes, map Ganymede's magnetic field, and search for signs of habitability beneath the ice. Their discoveries could redefine our understanding of life itself. For the first time, we may soon look into the oceans of another world. And when those spacecraft send back their images of blue, white glaciers, glowing auroras, and Jupiter rising above the horizon, humanity will see not just distant moons, but mirrors of our own oceans, our own sky, our own longing to know what lies beyond. These moons, orbiting in the giant shadow, remind us that even in the coldest, darkest corners of the solar system, the potential for wonder, and perhaps life, endures. Jupiter's moons are not mere satellites. They are a living symphony of motion and silence, fire and ice, age and renewal. Together, they tell a story of balance, how the universe creates harmony through contrast. Around the giant planet, time flows differently. Volcanoes burn while oceans freeze, ice glows while rock melts, and amidst it all, Jupiter watches, serene and unending. Its moons, caught in the curve of its gravity, orbit not in servitude, but in eternal partnership, each one a note in the great music of the cosmos. For as long as our solar system has existed, Jupiter has been both protector and destroyer, a cosmic force that has shaped the destiny of every planet and moon orbiting the Sun. Its mass, more than twice that of all the other planets combined, makes it the gravitational anchor of our celestial family. Without Jupiter, the solar system as we know it might not exist. Its presence has influenced the orbits of worlds, sculpted the paths of comets and asteroids, and perhaps even safeguarded the fragile cradle of life on Earth. Jupiter's legacy is written not only in its own storms and moons, but in the very history of our planet. To understand Jupiter's influence, we must look back to the dawn of the solar system over 4.5 billion years ago. In those chaotic beginnings, the Sun was still young, surrounded by a vast disk of gas and dust. Within this swirling nebula, countless fragments collided and merged, forming the seeds of future planets. Amidst this violent creation, one body grew faster and larger than all the rest: Jupiter. It consumed the lion's share of hydrogen and helium left over from the Sun's formation, growing until its gravity dominated the region. It was, in many ways, the solar system's firstborn, a world that dictated what the rest would become. As Jupiter's mass increased, its gravitational pull began to influence everything around it. The powerful tides it raised in the solar nebula prevented nearby material from clumping together. The result was that no large planet ever formed between Jupiter and the Sun, leaving only small, rocky worlds like Earth and Mars. The asteroid belt, that broad expanse of rocky fragments between Mars and Jupiter, is a monument to this disruption. A region where Jupiter's constant tug stopped the building blocks of planets from ever coalescing. Each asteroid, there is a remnant of what might have been. A frozen chapter of creation left unfinished because of Jupiter's immense gravity. But Jupiter's role was not just one of destruction. Its gravitational field also acted as a shepherd, gathering smaller objects, guiding them into stable orbits, and in many cases protecting the inner planets from catastrophe. Many comets and asteroids that might have threatened Earth were instead deflected or absorbed by Jupiter's presence. Astronomers sometimes call it the cosmic vacuum cleaner of the solar system, an apt description. Though it's less a cleaner than a guardian, its gravity redirects countless would-be impactors, sparing Earth from collisions that could have extinguished life before it began. This role became dramatically clear in 1994, when the comet Shoemaker, Levy 9, collided with Jupiter. The comet had been captured and torn apart by Jupiter's gravity the year before, breaking into dozens of fragments that plunged into the planet's atmosphere one by one. The impacts released energy equivalent to millions of nuclear explosions, leaving scars larger than Earth itself on Jupiter's clouds. Yet those scars were fleeting. Within weeks, the planet's atmosphere had swallowed them whole. The event was a cosmic reminder of Jupiter's power and of the safety it offers. Had that comet crossed Earth's path instead, it might have ended all life in an instant. Jupiter's gravitational reach extends far beyond its moons and belts. It shapes the paths of comets that come from the outer reaches of the solar system, sending some inward toward the Sun and flinging others outward into the darkness beyond Pluto. The orbits of many long-period comets are sculpted by Jupiter's invisible hand. Even the architecture of the distant Kuiper Belt, the realm of icy worlds at the solar system's edge, bears the subtle mark of its influence. Jupiter's gravity, working in concert with Saturn, acts as a cosmic metronome, setting the rhythm of planetary motion that has remained stable for billions of years. And yet, for all its grandeur, Jupiter's influence is not limited to celestial mechanics. Its existence has shaped the very conditions that made Earth habitable. In the early days of the solar system, when the young sun burned hotter and the inner worlds were still molten, Jupiter's migration through the solar disk may have altered the flow of material toward the Sun. Some theories suggest that as Jupiter formed, it drifted inward before settling into its current orbit. In doing so, it may have pushed rocky debris toward the inner system, the same material that eventually formed Earth. Later, as the planet moved outward again, it could have helped deliver icy comets and water, rich asteroids inward, seeding the early Earth with the water that fills our oceans today. In this sense, Jupiter may have played a silent, crucial role in the emergence of life. Jupiter's magnetism, too, extends its influence far and wide. Its magnetic field, the largest structure in the solar system aside from the Sun's own, creates a vast magnetosphere, an invisible bubble of charged particles that stretches millions of kilometers into space. Within it, particles from the solar wind are trapped and accelerated, producing stunning auroras at the planet's poles. These auroras are the most powerful in the solar system, visible even from space-based telescopes orbiting Earth. They serve as a visual reminder of Jupiter's energy, its constant conversation with the Sun through fields of magnetism and light. Even beyond our solar system, Jupiter's legacy echoes. In recent decades, astronomers have discovered thousands of planets orbiting other stars, exoplanets. Many of these are hot Jupiters, gas giants orbiting extremely close to their suns. Their discovery reshaped our understanding of how planetary systems form and evolve. It revealed that Jupiter, like worlds, are not rare. They are common, perhaps essential, in shaping the architecture of planetary systems everywhere. By studying Jupiter, we learn not only about our own origins, but about the nature of countless other systems scattered across the galaxy. It is astonishing to realize that a planet made mostly of hydrogen and helium, the simplest elements in the universe, holds such complexity and power. Its gravity binds, its storms rage, its magnetism hums through space. Every force that Jupiter exerts is a thread in the grand tapestry of creation. Its presence stabilizes the solar system, ensuring that orbits remain steady over billions of years. Without it, chaos might reign. Planets colliding, orbits shifting, worlds lost to the sun's pull. Jupiter's balance allows the fragile harmony of our system to persist. It is not simply a planet. It is the solar system's great regulator. And in that role, it also reminds us of our place in the cosmic order. We often think of Jupiter as distant and abstract, a distant point of light in the night sky. But every breath of air, every drop of water, every heartbeat on Earth has been influenced in some way by that far-off world. The calm of our sky, the steadiness of our seasons, the stability that allowed life to evolve, all are products of a universe in balance, a balance that Jupiter helps maintain. As we look deeper into space, we begin to see echoes of Jupiter everywhere. In the massive exoplanets orbiting other stars, in the swirling disks of gas where new systems are born, in the magnetic storms of distant giants. The study of Jupiter is, in many ways, the study of creation itself. Its storms mirror the chaos from which stars are born. Its moons reflect the diversity of worlds that might exist across the cosmos. Its gravity teaches us that structure and stability emerge not from stillness, but from motion and interaction. In centuries past, ancient astronomers watched Jupiter with reverence. To them, it was the king of the planets, a symbol of power and wisdom. In mythology, it ruled over gods and men alike. Today, with our telescopes and spacecraft, we see beyond myth, yet what we find only deepens that sense of awe. The king still reigns, not by decree, but by nature's design. Its dominion is not measured in kingdoms, but in the arcs of orbiting moons and the calm it bestows upon a system vast beyond comprehension. When the Juno spacecraft arrived at Jupiter in 2016, it entered a dance that had lasted since time immemorial. Each orbit brought new discoveries, images of storms, readings of gravity, whispers of magnetic fields. Juno revealed that the Great Red Spot reaches deeper than anyone imagined, that the planet's poles are home to enormous cyclones arranged in geometric patterns, and that its core may be a swirling blend of elements. Even now, as it continues its mission, Juno circles the giant like a silent messenger, translating the language of a world that speaks in magnetism and motion. And still, despite all we have learned, Jupiter keeps its secrets. It invites us to wonder, to gaze upward at that bright, steady light in the night sky and remember how much remains unknown. Its presence is a reminder that exploration is endless, that mystery is the foundation of discovery. The more we learn about Jupiter, the more we learn about ourselves, our curiosity, our smallness, our connection to the vast machinery of the cosmos. One day, when humanity has reached the outer planets and perhaps built stations on their moons, Jupiter will no longer be just a distant wonder. It will become a frontier, a place where explorers gaze upward at its cloud tops, watching storms the size of continents drift slowly beneath the stars. They will see, perhaps for the first time, what it means to live in the shadow of a giant. And when they look back toward the tiny blue dot of Earth, they will understand that the harmony of their home, the life that thrives there, was shaped, in part, by the enormous guardian whose light they now orbit. Jupiter's story is not one of chaos, but of balance. It is the universe reminding us that greatness and gentleness can coexist, that power can nurture as well as destroy. From its birth in the solar nebula to its endless storms today, Jupiter has been a silent architect, sculpting the world we inhabit and the future we imagine. Its gravity holds our past, its mystery beckons our future. And though it will continue to circle the sun long after we are gone, its legacy will live wherever life looks up and wonders how the heavens came to be. In the quiet of night, when you lift your eyes and see that faint, golden orb glimmering among the stars, you are seeing more than a planet. You are seeing a story, one that began before Earth formed and will continue long after it fades. You are seeing the guardian of worlds, the remnant of creation, the eternal witness to time itself. You are seeing Jupiter, the king of planets, and in its reflection, the enduring memory of the cosmos.